And number 14, the growth rate of the sunflower from day 14 to day 35 is nearly constant. On this interval, which of the following equation best models the height in centimeter of the sunflower T days after it began to grow? Okay, so we're trying to write an equation to model the graph from day 14 to day 35. So again, we had to go back up. So this question is also similar to question 13, right? So it's like linear model, but except here, we're trying to figure out the actual number to write out the equation. So if we go up a little bit here from 14 to 35, and I'm going to kind of go back and forth here. So 14 and 35, you see, yeah, day 14 to day 35, this is like a straight line. Okay, so we're trying to write out the equation for this to model the straight line. Okay, so what we can do is we can just kind of pick out 2 points on the graph, right? And then we can solve for the slope. And if needed, we can just also solve for the y-intercept. Okay, so let's just pick 2 points. Doesn't matter which one you pick. Preferably is, points that are closer. Yeah, it seems like all these points here, we pretty much have these 4 points that we can use, right? So let's just pick the first 2 then, because none of them are exactly on the grid. So we can do this point at 14, right, is what, it's like a little bit less than 40, right? So I would say it's like 38 maybe. Okay, 14 comma 38. And then at 21, let me write this down, 14 comma 38, that's what we pick. And then at 21 it's about a little bit less than 70, right? Or maybe 68. Let's just say it's 21 comma 68 maybe. Let's just say that. Okay, so we get 1438 and then 2168. Okay, so 14 comma 38, 21 comma 68. That's a 2 point that we pick for that interval. And then if we have these 2 points, we can just use those 2 points and then solve for the slope. Okay, here we can use a slope formula. All right, so the slope formula, slope is equal to y2 minus y1 over x2 minus x1. All right, so if you have any 2 points, you can use this formula to solve for the slope. And that will be the number in front of the t, and that will be the slope. Okay, so again, plug in and solve. So y2 minus y1. If you want, we can label this x1, y1, x2, y2. So y2 minus y1 is going to be 68 minus 38 over x2 minus x1 will be 21 minus 14. Okay, so solve that, that will be 30 over 7, right? 30 over 7. And then we can just go and type into a calculator. This should give us 4.28. Okay, or 4.3 if you round it. All right, so the slope should be close to 4.3. So it might be a little bit off because we're just picking point, right? The points are not exactly on the grid, but we know it should be pretty close, right? Because we try our best to kind of estimate using points. So the slope should be 4.3. And if we look at close to 4.3, so look at the answer choices, which one is the closest? It had to be letter B, right? Letter B, we have the slope is 4.5. The other ones is pretty far off, right? So the difference is big enough that we know it should be just letter B. Okay, so if we have the slope are pretty close, right, then we have to use the y-intercept. To solve for y-intercept, we can actually plug in a point, right, into the slope-intercept form. So we know y equal to, let's say, 4.3x, right, plus b, we can plug it in and solve for b and to check the y-intercept, right, which should be also close to negative 27. But here we don't have to do that, okay, because the slope, the answer choice, the slope the difference are big enough. We know it should be b. Okay, the other ones are not even close to what we have. Okay, so for number 14, B is the correct answer.